Hey guys, welcome to another session with SSF Tutorials. Today we are going to continue with our exercise 8.1 part 3. We have continued the previous sums in our part 1 and part 2. So you can find those videos. I'll leave a link in the description box, so from where you can directly find those videos. So now let's start with the question number 8, which states if 3 cot A is equal to 4, check whether 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A or not. So for this question we have to prove that 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A, if it is true or not. So let's just draw a relevant diagram for the question, so which is going to be like this. Basically for all the questions we have to draw a right angle triangle. So now let's name the triangle as A, B and C. The triangle is right angled at B, as you know. Angle A is going to be an acute angle and angle C is going to be an acute angle. Now let's start with the question. The given data to us from the question is that 3 cot A, let's write it as given data, that is 3 cot A is equal to 4. Now guys, now we have to just modify this equation. Like you can see this 3 in the LHS. You have to send this 3 to the RHS. So the equation which we get further is cot A is equal to 4 divided by 3. So the trigonometric ratio for cot A, as we know, it is cot A is equal to adjacent side divided by the opposite side. So we have to just see the diagram. So the angle is been found with respect to A. So from A, the adjacent side is going to be AB and the opposite side is going to be CB. So we know cot A is equal to 4 divided by 3. So AB is going to be 4 and CB is going to be 3. So now let's just enter the values in our diagram. AB is 4 and CB is 3. So we can clearly observe that the hypotenuse side is not given. So we have to find it by the Pythagoras theorem. So now let's just find it by Pythagoras theorem. It's gonna be AC square, which is the hypotenuse side, is equal to AB square plus CB square. So from the diagram we know that AB and CB values are already given. So let's enter them in the equation. AC square is equal to AB, that is 4, so it's going to be 4 square, plus CB, that's going to be 3, so it's going to be 3 square. So now let's write it. That's equal to 4 square is 16 plus 3 square is 9. So 16 plus 9 is going to be 25. So now by transferring the square from the left hand side to right hand side, it's going to be AC is equal to root 25. Now guys, we know that root 25 is 5, so AC is going to be equal to 5. Let's enter the value in our diagram. Yeah, now let's proceed to the proving part, which we have to prove, that is 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A. This is true or not? That's what we're gonna prove. So for our reference, let's just write the equation below. So which equation, if you guys are thinking, is just this equation which I'm going to write it. So now let's write it. The equation is 1 minus tan square a divided by 1 plus tan square a, that's equal to cos square a minus sin square a. So let's divide this equation into two parts. Like, let's divide this part of the equation as LHS, which is going to be the left hand side of our equation, and this part of the equation, let's name it as RHS. So let's first consider the LHS part. So let's just write it. 1 minus tan square a divided by 1 plus tan square a. So now let's just try to find out the individual terms like tan, so that we can substitute the value in the equation. So so let's just find it. So the individual term, let's find it. That's equal to tan, that is tan a. So that's equal to, let's find out tan a. So the trigonometric ratio for tan is going to be opposite side divided by the adjacent side. So the opposite side in our diagram, let's see it. So we are finding with respect to a, so the opposite side is gonna be CB, which is this, and the adjacent side with respect to a is gonna be AB. So we know. Now let's write it. So that's gonna be equal to BC divided by AB. So what is the value of BC? That is 3. And what is the value of AB? That is 4. So let's just write it there. That is 3 divided by 4. So now let's just write this value, substitute this value, to this equation. So what are we gonna get? Let me just write it this side. Okay. Yeah. So that's gonna be 1 minus. So we know what is the value of tan A, that is 3 divided by 4 to the whole square, divided by 1 plus 3 divided by 4 whole square. So 1 minus, so let's rewrite the equation. 1 minus 3 square is 9, divided by 4 square is 16. That's divided by 1 plus the same 9 divided by 16. So now we know the LCM for the equation is 16, which is this. So now let's equate the numerator as 16 minus 9 divided by 16 divided by 16 plus 9 divided by 16. So since we can clearly observe that the denominator for the upper equation and the lower equation are the same, so we can just cancel it just like this. So which will lead us to a new equation that is equal to 16 minus 9 divided by 16 plus 9. 16 minus 9 is equal to 7, divided by 16 plus 9 is 25. So this leads us to our LHS. That's equal to LHS. So now let's go on with our finding of RHS. So RHS term is this. So let's just write it below. Cos square A minus sin square A Let's do this similarity as we did it above. You have to find each term's value, that is so cos A and sin A. So cos A is equal to adjacent side divided by the hypotenuse side, which is the trigonometric ratio for the cos. For sin, the trigonometric ratio is going to be opposite side divided by the hypotenuse side. So just now let's just find the values in our diagram. So the adjacent side for cos and the hypotenuse side. So here we can clearly indicate that the hypotenuse side AC is common for sin and cos. So the adjacent side is going to be AB for cos, that is 4, and the hypotenuse side is AC as I told you. Then the opposite side for sin is going to be CB, and the hypotenuse side is going to remain the same, that is AC. So now let's just enter the value in our equation. As I told, the adjacent side for cos is AB divided by AC, that's equal to, what's our AB value? Let's just see it again. AB value is 4 and AC is 5, so it's going to be 4 divided by 5. And for sin, that is BC divided by AC, as I just told you. So what's the value of BC? BC value is 3 and AC value remains the same, that is 5, so it's going to be 3 divided by 5. Now let's just enter the both the values in the equation, this value and this value, in our equation, which is this. So that's going to be cos square A minus sin square A. I'm writing it again so that you don't get confused with the equation. So that is going to be equal to cos square, as we found, it is 4 divided by 5. So let's just enter it, 4 divided by 5 square minus sin. What's the value of sin? 3 divided by 5 to the whole square. So now 4 square is 16 divided by 5 square is 25 minus 3 square is 9 divided by 5 square is 25. Since our denominators are same, so the LCM is going to remain the constant, so it's going to be 25 divided 25 is going to remain constant, that's going to be upper, so that is the numerator is going to be 16 minus 9, so that's equal to 7 divided by 25. So that is our RHS. So what we had to prove in our equation, now question, we had to prove whether 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A or not. So what have we got the value for 1 minus tan square A divided by 1 plus tan square A? The value is 7 divided by 25, which is here. The value for our second part of the equation, that is the RHS cos square A minus sin square A, we got it as 7 divided by 25, which is here. So hence our answer is going to be LHS is equal to RHS, that is 7 divided by 25 is equal to 7 divided by 25. So hence they are equal. Hence they are equal. So let's move on with the ninth question, which states that in a triangle ABC, right angle at B, if tan A is equal to 1 divided by root 3, find the value of sin A into cos C plus cos A into sin C. So let's start the question by drawing a relevant diagram for the question. So it's going to be a right angle triangle. It's given in the question that it's right angled at B. Right angle at B, so this part is going to be B and the leftover part is going to be A and C. So it's given in the question that tan A is equal to 1 divided by root 3. The trigonometric ratio for tan, as we know, it is opposite side divided by the adjacent side. So in this figure we are finding it with respect to angle A, so which is here. So the opposite side to angle A is CB and the adjacent side is AB. So that is equal to the value which is given to us, 1 divided by root 3. So CB is going to be 1 if we compare whatever we found it just now. So AB is going to be root 3. We can clearly indicate that the hypotenuse side is not given to us. So let's find it by using the Pythagoras theorem. By Pythagoras theorem, the formula is going to be AC square is equal to AB square plus CB square. So AB square, the value of AB is root 3, so it's going to be root 3 to the whole square, plus CB value is 1, so it's 1 to the whole square. As we know, the square of root is going to be cancelled out, so we get the answer as 3 plus 1 square is 1, so it's going to be 4. By transferring the square in LHS to RHS, so it's going to give us AC is equal to root 4. Square root of 4 is 2, so the answer is going to be 2. So AC is going to be 2. Let's enter the value in our diagram. That is equal to 2. So in the question, the equation is given to us as sin A into cos C plus cos A into sin C. So let's write down this equation below. Sin A into cos C plus cos A into sin C. So now let's find the values by taking our individual term from the question. First let's find out sin A and cos C. So sin A is equal to opposite side divided by the hypotenuse side, which is the trigonometric ratio for sin, divided by the hypotenuse side. So the opposite side, as we see in the figure, is CB and the hypotenuse side is AC. So let's write it, CB divided by AC. So the value of CB in the figure is, let's see, what is the value of CB? It is 1 and AC is 2, so it's going to be 1 divided by 2. For cos, the trigonometric ratio is equal to adjacent side divided by the hypotenuse side. So the adjacent side with respect to angle C. So let's see, angle C is here. So with respect to angle C, the adjacent side is CB divided by the hypotenuse side, that is AC. So let's write it. So the angle CB, sorry, side CB divided by the hypotenuse side AC. So the value of CB is 1 divided by the hypotenuse side, that is 2. So it's going to be same as we found it, 1 divided by 2. So now let's go on to find the other part of the equation, that is cos A plus cos A into sin C. Let's find it. Fine. So now let's find the individual terms, cos A into sin C. So that let's find out sin C also as individual term. So cos, as we know, the trigonometric ratio, which we found it here, adjacent side divided by the hypotenuse side. So I'm just going to name it as A divided by H. A indicates adjacent side, H indicates the hypotenuse side. So the adjacent side in our figure for cos A is going to be AB divided by the hypotenuse side, that is AC. So it's going to be AB divided by AC. The value of AC, as we know, it's 2. AC is 2 and AB is 1. The value of AB in our diagram is root 3 and the value of AC in our diagram is 2. So let's write it. So it's gonna be root 3 divided by 2. For sine, the trigonometric ratio, as we just saw in a previous thing, it's going to be opposite side divided by the hypotenuse side. So I'm just going to write it as O divided by H, where O indicates the opposite side, where H indicates the hypotenuse side. The opposite side in the diagram is going to be with respect to C. It's going to be AB divided by the hypotenuse side AC. So let's write it. AB divided by AC. So now let's see what is the value of AB in the figure. AB value is root 3 and AC value is 2. So it's going to be same, root 3 divided by 2. Now let's enter all these values, all these 4 values in our equation. In our equation, which is provided here, let's write it below. Sin A value, as we know, it is sin A value, as we know, it is 1 divided by 2 into cos C value, it is 1 divided by 2 plus what is the value of cos A, which is root 3 by 2. Value of sin C is also root 3 by 2. So in simple terms, the equation is going to be 1 by 2 whole square plus root 3 by 2 whole square. If you want, you can skip this step. I just wrote it so that you can understand what I'm doing. So 1 divided by 2 is going to be 1 divided by 4 plus root 3 square is 3 divided by 2. Square is 4. So as we know, the denominator is same for the equation. So the LCM is also going to be same, that is 4. So it's the numerator is going to be 1 plus 3. So that gives us 4 divided by 4. 4 by 4 get cancelled and the answer is 1. So guys, let's move on to our last question, which is question number 10, which states that in a triangle PQR, right angled at Q, PR plus QR is equal to 25 centimeter and PQ is equal to 5 centimeter. Determine the value of sin P, cos P and tan P. So now let's draw a relevant diagram for the question, which is going to be like this. it's also going to be a basically a right angle triangle. So in the question it is given that the triangle is right angled at Q. So the point Q is going to be the angle which is located near the 90-degree angle. So this is going to be Q. So the other points are going to be, this is going to be P, Q, and this is going to be R. So in the equation we have an equation which states PR plus QR is equal to 25 centimeter. Now let's write this equation in our solution. PR plus QR is equal to 25 centimeter. By sending QR to the RHS, we can rewrite the equation as PR is equal to 25 minus QR. So let's name this equation as equation number 1. So now let's enter the value of PR in the diagram. So PR is equal to 25 minus QR. In the diagram it's given as PQ is equal to 5 centimeter. Let's enter this also. So it clearly shows that RQ is missing. So let's find this side by using the Pythagoras theorem. So which by Pythagoras theorem is going to be equal to the hypotenuse side, that is PR square is equal to RQ square plus PQ square. So now we know the value of PR, that is 25 minus QR whole square, that is equal to RQ with the value we don't know, so let's write it as it is. PQ value is 5 centimeters, so that's going to be 5 whole square. You can clearly see that the left hand side is in the form a minus b to the whole square. So let's name the individual terms, like 25 let it be as a and QR let it be as b. So we know by expanding the formula a minus b to the whole square, it's going to be a square. So let's write the formula: a square plus b square minus 2ab. So now let's substitute. So a square, as we know, that is 25 whole square plus b square, that is QR square, minus 2 into 25 into QR. So 25 square, as we know, it is 625 plus QR square minus 2 into 25 is 50 into QR. So now let's substitute this value in the equation. So that's going to give us 625 plus QR square minus 50 QR is equal to RQ square plus 5 square, that is going to be 25. So now here we can see that this QR square and RQ square are both the same. If you just make this R, this come this side, it's going to be RQ square. So we can cancel these both terms. So the left out equation is going to be equal to 625 minus 50 QR is equal to 25. So that's going to be equal to 625 minus 25 is equal to 50 QR. I send the 50 QR to the right hand side because I just wanted to eliminate that minus sign, so I just send it to the right hand side. So 625 minus 25 is going to give us 600. So that's equal to 50 QR. So now by sending 50 towards the left hand side, that's going to be cross multiplication, so it's going to give us 600 divided by 50, that's equal to QR. So the zeros are going to get cancelled here, and 5 divided by 60 is 12, so QR is equal to going to be 12. So now let's just write this value in our diagram. QR is going to be equal to 12. And now as we took our first equation, that is PR is equal to 25 minus QR. So now let's just enter the value of QR in this first equation. So let's write it like by first equation, I'm going to write equation. So let's write the equation, that is, let's write the equation, that is PR is equal to 25 minus QR. You can just see above me the value of QR is just been proved here. So let's substitute the value. PR minus is equal to 25 minus 12, that is going to give us the answer 13. I took a time for calculating the value, sorry. PR is equal to 13. So now let's just enter this value in our diagram. That's equal to 13. I'm going to rub this 25 minus QR for you. So here you go, it's going to be like this. So now let's find the determining the value of sin P, cos P and tan P. So we have got to find sin P, cos P and tan P. So let's write it. Let's write the trigonometric ratios first and then let's find the values. Sin P, that's going to be equal to opposite side divided by the hypotenuse side. And cos P is going to be equal to adjacent side divided by the hypotenuse side. Tan P is going to be equal to opposite side divided by the adjacent side. So now let's just see what is the opposite side with respect to angle P. With respect to angle P, the opposite side is RQ. So if you don't know where is the angle P is here. So the opposite side is RQ, the hypotenuse side is RP. So let's write it. RQ divided by the hypotenuse side, that is PR. So now let's just substitute the value. So RQ is 12 and PR is 13, so it's going to be 12 divided by 13. So for the cos P, let's see what's the adjacent side and the hypotenuse side. So with respect to angle P, the adjacent side is PQ and the hypotenuse side is going to remain the same, that is PR. So let's write it. That is equal to PQ divided by PR. PR is going to be same here, so that is going to be 13. So PQ is 5. So let's write it. So for tan P, it's going to be opposite side divided by the adjacent side. So the opposite side for the angle P is RQ and the adjacent side is PQ. So let's write it. RQ divided by the adjacent side, that is going to be PQ. So that is going to equal to RQ, as we know in the sign here, is equal to 12, and PQ value is 5. So let's write it. So here we complete the sum. And guys, please don't forget to like, share and subscribe my channel, and do press the bell icon to get the latest notifications about my channel.